Hi, welcome to the solution video of the 11th foundation assignment of the STEP support programme, where we are solving equations with square roots in. And these initially might look quite daunting because they might not be like anything you've solved before, but the question does guide you through some hints and tricks you can use to go about solving these. So let's start with 3i. Where we're using the substitution square root of x is equal to y, where y is greater than or equal to 0, to find the real root of this equation. And I think just to start it might be worth underlining where y is greater than or equal to 0. Step questions tend not to give you any redundant information, so this might be worth just keeping in the back of our minds to use later on in the question. Seems like something I might forget as we're just going on. And yeah, so let's just start by using this substitution it tells us to. So let's let y is equal to square root of x. And we are also replacing an x in the equation. So it might also help to say that y is equal to x, sorry, y squared is equal to x. Just by squaring both sides. You don't have to write this down. I just think it might make things a little bit clearer to keep us on track. And yeah, let's go ahead and just substitute these in. So we get y squared plus 3y minus a half is equal to 0. And already this is looking way more like something we can solve because it's of the form of a quadratic. Hopefully you've solved many of these before. And just by looking at it, I'm not sure whether I can factorise this. So I think I might just go ahead and use the quadratic formula. So we have y is equal to minus 3 plus minus square root of b squared, so that's 9, minus 4ac, so that's plus 2 all over 2. And if you haven't committed the quadratic formula to memory yet, I think it's a good idea to sooner rather than later, as it comes up like way more than I expected it would, just when solving quadratics like this. So, sorry, if I scroll down a little bit. Let's see if we can simplify this. So we get minus 3 plus minus square root of 11 all over 2. And this is where what we underlined comes back to be helpful, where y is greater than or equal to 0. So obviously if this takes the minus, we have y is equal to minus 3 minus root 11, that's going to be less than 0. But if we take the plus square root, we have y is equal to minus 3 plus root 11 over 2, which is greater than or equal to 0, so that's fine. So we can say because y is greater than or equal to 0, have y is equal to minus 3 plus root 11 all over 2. Okay, so we've got our value of y. Now this isn't sufficient. It wants us to find the real root of the equation in x, so we do need to give a value of x. But luckily we did write down earlier from our substitution that y squared is equal to x. So to find x we need to square our value of y. So we have x is equal to y squared is equal to minus 3 plus root 11 all over 2 squared. So first squaring the numerator we get 9 minus 6 root 11 plus 11 all over squaring the denominator we get 4, which is equal to 20 minus 6 root 11 all over 4. So if I just scroll down a little bit more, we get is equal to 10 minus 3 root 11 all over 2, which is our required answer. This gives a value of x that solves this equation. Great. So I'm happy we're completely done with this just by rereading the question. So I think it's time for us to go on to 3 part 2. And this is split up into an A and B, so let's do the A first, where we're finding all real roots of the following equation. Now this is in a very similar form to part I, where we've got x plus some kind of square root of x. Here we've got an x plus 2 instead, that's actually the main difference, minus some constant is equal to 0. So I'm not really sure how I'd go about solving this, so I think maybe I'll try to relate it back to part I and use a similar technique. So here they took the substitution of this square root. Let's do the same here. Let's take y equals square root of x plus 2, this square root, and see what that does for us. It might not end up working, but I think that seems like a good thing to try first. So this gives, again, y squared is equal to x plus 2. And this isn't going to be quite as straightforward to substitute it in, but let's do what we can. So we have x plus 10y minus 22 is equal to 0. So that's just by replacing this root of x plus 2 with y. But we've still got an x we need to get rid of. Luckily we can find x in terms of y just by using this. We say that x is equal to y squared minus 2. Just again from our substitution by rearranging it. So we can substitute that back in to get all of the x's in terms of y's. So plus 10y minus 22 is equal to 0. If we just group the terms, we get y squared plus 10y minus 24 is equal to 0. This is looking a lot more like, again, something that we can solve. So I think it might be worth seeing if we can factorise this, because we've got integers, we don't have any fractions like we did last time. And indeed, if we think about it a little bit, we get y plus 12 multiplied by y minus 2 equals 0, expands to give the result. Because 12 and minus 2 multiply to give minus 24, and 12 and minus 2 add to give 10. If you don't think you'd have seen that, using the quadratic formula is completely fine, but it does take a little bit longer. So this gives us two values of y again. We have y is equal to 2, or y is equal to minus 12. It's important we say the or here. They're not both true at the same time. One is true or the other is true. Because y can't have both values at the same time. Okay. Note that y is equal to this square root. And square roots have to be positive. So we can say note y is equal to square root of x plus 2. You might see where this is going, which is greater than 0. So we can ignore this y is equal to minus 12 solution to give y is equal to 2 as our only solution. And this is looking good because it's similar to part I, where we found two values of y and we ignored one of them to just give y is equal to this, because y is greater than or equal to 0. Sorry, I've just noticed this should be greater than or equal to, square roots can equal 0. Okay, so y is equal to 2. Now let's again get this in terms of x. We have x is equal to y squared minus 2. So let's write that down here. Is equal to 4 minus 2, which is equal to 2. Okay, we found a value of x. You can, if you want, verify this for yourself that it does indeed satisfy the following equation. So we're done with II part A. We found a real root of the equation. Okay, so let's now go on to II part B, where we're still finding all the real roots of this equation, but the square root's now a bit trickier to deal with. And I think, again, I don't know how I'd go about solving this other than using a similar method to the other two parts, where we take a kind of y substitution that's equal to the square root. So I think, again, I'm going to try that. It might not work, but I think it will at the very least tell us some information on how we can solve the question. So let's try it. We have let y is equal to the square root of 2x squared minus 8x minus 3. And again, this gives y squared is equal to 2x squared minus 8x minus 3. So this is just setting y to be equal to this square root. And we'll see what happens. So let's try to substitute it in. It might again take a couple of lines to replace all of the x's with y's, but we'll give it a go. So we can start off with x squared minus 4x plus y minus 9 is equal to 0. And now let's try to replace this x squared and minus 4x with y's. And we do see that y squared is equal to some function of x squared and x. So let's maybe get both of those on one side and get the rest of stuff on the other side and see what happens. So we have y squared plus 3 is equal to 2x squared minus 8x from our substitution here. And we can actually see that if we halve this, we get the x squared minus 4x that we need. So we have x squared minus 4x is equal to half y squared plus 3. So this is all just from rearranging our substitution. And like it very conveniently, it's almost as if the question was designed this way, lets us substitute our x's for y's. So half y squared plus 3 replaces x squared minus 4x plus y minus 9 is equal to 0. And I'd like to get rid of that half, so let's multiply it by 2, the whole equation. So y squared plus y squared plus 3, because that 3 is in brackets, plus 2y minus 18 is equal to 0. And now let's group these terms. So we have y squared plus 2y minus 15 is equal to 0. Now, does this look like something we can factorise, or are we going to have to use the quadratic formula? I think luckily for us, this time we can factorise it again. We can say y, if I scroll down a little bit, minus 5, or actually I think it might be a plus 5, y minus 3 is equal to 0. And just verifying this, plus 5 and negative 3 multiply to get negative 15, perfect. And positive 5 adds negative 3 adds to get 2. So that's perfect. So this gives our solutions as being y is equal to minus 5 or y is equal to 3. And exactly the same as last time, y is equal to a square root, which must be greater than or equal to 0. So we can't have y is equal to minus 5. We must have y is equal to 3 because y is greater than or equal to 0. And I'm feeling a lot more confident at this point because everything we did before is kind of now led towards something that's similar to the previous parts, even though we were a bit unsure about the substitution. But we ended up with the quadratic, we solved it, we eliminated one of the solutions, exactly the same as we did for the other two parts. So I'm happy, I'm more confident now. So what did we do in the other two parts? We replaced the y with an x, because we want to find the real roots of the x equation. So, okay, let's use y squared is equal to 2x squared minus 8x minus 3. This is looking like it's going to be a bit harder than it was last time, but I think we've come this far, let's just press on and see what happens. So we have y squared is 9 is equal to 2x squared minus 8x minus 3. Let's copy that down. 2x squared minus 8x minus 3. Let's group the terms. So we have a quadratic here. When it's 8x minus 12 is equal to 0. And we want the coefficient of the x squared to be 1 potentially. So let's say x squared minus 4x minus 6 is equal to 0. Now, I don't think this is something we can factorise again, so I'm going to use the quadratic formula to find our value of x. So we have x is equal to minus b plus minus square root of b squared, which is 16, minus 4ac, so that's minus 4, a is 1 and c is minus 6, all over 2a, but a is 1. Okay, let's simplify this a little bit. Inside the brackets we get 16 minus 4 times minus 6, that's add 24, so we get root 40 all over 2. Root 40 we can factor out the 4 to give 2 root 10 all over 2. And finally we can divide it by the 2 to give 2 plus minus root 10 as our value for x. And you'll notice actually that we have two values of x here, which might be a bit surprising, it wasn't similar to the other two parts, but if we do read the question, find all real roots, kind of reassures me a bit, that we're not just looking for one, we might have multiple. And you can actually substitute in these values of x yourself if you'd like, and see that they do indeed satisfy this equation. And we're done. We found two values of x here, we found one value of x for both other parts. These are the roots of the equation, and that's the end of the question. Bye.